hello there and welcome. Hello, this is Aurora with Central Coast Astronomical Society, and we are going to be joined very soon by Brian, who is currently out there trying to align his telescope. So we had a little bit of trouble. He's going to be back here just for a minute, but I thought we would chat before we get started. I am so glad that you are joining us. So how have you been? I think it's been too long since we've been stargazing. What do you think? Okay, so those of you who are members of the Central Coast Astronomical Society, you can, well, if you've never heard of that. So we have Central Coast Astronomical is an organization on the Central Coast of California, halfway between Los Angeles and San Francisco, and we do stargazing. And what the fun thing is that we actually have some stargazing dates that are going to be coming up in hopefully May, by for sure June, July, August, September, and October. So I'm still working out a couple of little details, which is why it's taken a little while to get those released. But we will be stargazing live in person on the Central Coast in this area, and so I'm excited to be able to do that this summer with all of you. Okay, so while Brian is getting ready, I have a couple of quick announcements. Here, let me make myself full screen here. If you could let me know, astronomically speaking, where are you on the planet right now? So go ahead and type it into the comments. You should be able to see comments on YouTube right now. Go ahead and type it in. Let us know where you are connecting from so we can be sure to include something that is on your side of the planet. So and it's also, yeah, me too. I'm excited. So we are going to have lots of fun tonight. If you've never stargazed before, this is a great place to get started because we're going to point out some things that you're going to be able to see. So our goal is that when you're done with this evening's presentation, it's about 45 minutes long, you will be able to go outside, look up, as long as there's no clouds and it's not raining, you'll be able to, if you can see stars, you'll be able to go outside, look up, and know where to look and know what it is that you're looking at. So that's our personal goal for you. And so to be able to do that, we actually do recommend some star charts. These are available for free at skymaps.com. If somebody wants to type that into the chat, that would be fantastic, but skymaps.com. And it's, you print it usually front and back. I printed mine on large things. How this works is this is the night sky when you look up. So you put this thing up over your head and then you align, it says north and west, you align two of those, and then this is actually what's projected on the night sky. Now, granted, when you're outside, being able to see one of these is sometimes a little difficult. Some people use apps on their phone. That's great. Sometimes that screen can be really bright. So what I recommend is going to do something like this, where we're going to be stargazing together, and I'm going to be able to answer questions as we go through. And then so as we're stargazing, as you can see, some of these have been highlighted. I just did another stargazing session with kids. And so we were highlighting different ones. And then when we're done with this presentation, watch it again, but just on audio, and keep it like in your pocket. And then you'll have this and you know what we just went over. So it'll be really easy for you to find the different constellations because we just talked about them. And so that's a fun way to do this. The other side of this actually has on there, these are easily seen with your naked eyes. That means you don't need binoculars, you don't need a telescope. You can just go outside and take a look at these as long as you have clear, dark skies. So we're not in the middle of New York City or San Francisco. We are out in the country where you can see stars and see some good detail. And then this section is binoculars, and just down here, the lower third, this is telescope. So most of this stuff, most people have access to, which is really fun. So this changes every single month. So make sure you get your hands on that. And so many thanks to, I forget the name of the fellow that makes this. He's been doing it for years. And so he does a fantastic job, and they're free, which is great. Oh, Brian, hi.
Hello, I'm here and I'm in focus.
Yay!
Both me and my telescope should now be in focus.
Oh, that's wonderful. So, Brian, what are we going to be doing tonight?
Well, we are going to actually really do live telescope views. The weather has cooperated for once. And I have 4 different objects lined up, and I have my first one actually ready to go. The first one we'll look at will be Venus, whenever we're ready to go.
I think we're officially ready. Should we say our official
Awesome.
welcome? So hello and welcome everyone. This is Aurora and Brian from Central Coast Astronomical, and we are so excited. We get to stargaze for real. Last time we got clouded out. So this is so fun. So we're going to look at Venus, is that right?
That's right. Venus will be our first object that we look at tonight.
All right, let's do it. Let's do it.
Okay, wonderful. So let me go ahead and share my screen here.
Sure.
So this is a view from my telescope that I have here in Southern California. And that right there is Venus. Now, it's going to be bouncing around a little bit because of our atmosphere. Now, of course, the sun has just set, and so the Earth is cooling, and all of that heat wave coming up from the Earth's surface is bending the light that's coming from Venus. So let's talk about some facts for Venus. And I think we should talk about the elephant in the room, or the planet in the picture. And notice that is not a round circle, is it? Believe it or not, Venus has phases just like the moon does. And so you can see here, this is not like an optical illusion or something from the camera, but it is actually just past a half Venus. And that is because we're looking at it as it's being lit from the side. Now, keep in mind that my telescope is flipping images around, but I'm going to change views here for just a moment. This is a view from NASA EYE's solar system. To give you an orientation, here's the sun in the middle. Here's Earth. So we're as if we're looking from Earth's point of view. And you can see here, then Venus is off here to the side. So Venus is being lit from the side, causing it to be in a phase. And we're seeing it lit, of course, sideways. So it's really neat over time to look at Venus with binoculars or your telescope and notice how different amounts of it are actually illuminated. I'll come back to the view of Venus. Now, Venus is indeed the second planet from our sun, but actually hotter than Mercury, believe it or not. We're looking at surface temperatures between 700 and 900 degrees Fahrenheit. That is hot. In Celsius, that's 390 to about 475. Why is it so hot, you might ask? Well, it's because it is covered in clouds and a tremendous amount of carbon dioxide. So you've heard of the greenhouse effect. Venus is an example of greenhouse effect to the extreme. In fact, it is a very extreme planet. It actually has clouds of sulfuric acid. Now, over the course of our space program for humans, we've tried to send probes to Venus. The most successful probe was the Soviet Union's Venera 13, and it only survived for just over 2 hours before the atmosphere beat it up to the point between temperatures and acids that it couldn't transmit anymore. That was back in 1981. And we have never been able to land anything and have anything go down to the surface ever since. Now, something that's interesting, and this actually just happened, we're recording this in April 2023. Just last month in March, scientists published a paper after analyzing Magellan surface radar images from over 30 years ago. Imagine how far our technology has advanced in 30 years when it comes to radar and space probes. But from analyzing that 30-year-old data with modern software, they see evidence that there are volcanic vents that seem to change shape and increase in size over an 8-month period of the radar image data that's been archived. That is indicating active volcanoes. So scientists are more and more starting to think that there could be active volcanoes on the planet Venus. Now, we have 2 upcoming missions that NASA is doing for Venus. One is called Da Vinci Plus, and it will measure the composition of the atmosphere. We know there's carbon dioxide, we know there's sulfuric acid, but we need a lot more details about the atmosphere. Veritas' main mission will be new high-resolution images of the surface, and they're going to be really after some of these vents and trying to analyze and count the volcanic activity that they have on the surface. So that is what I wanted to share about Venus. Have any other questions come in? I haven't had a chance to fire up my YouTube view yet.
No, but you got a whole bunch of wows.
Yes, I agree. That is a lot of wow.
Awesome.
Well, wonderful. Well, should we hop right over to our our next object?
Yes. What is
Okay.
our next stop? I don't even
Our-
know where we're going tonight. Usually you give me
Oh.
more detail.
Oh, yeah. Well, Aurora, if you visit centralcoastastronomy.org, just kidding. Next up will be the Beehive Cluster,
Okay.
M44, and it'll take me a moment to slew over there.
No problem.
And in fact, we're going to be looking at 2 open clusters in Cancer. So maybe if you wanted to take a moment, you can show folks where they might go.
I can,
Wonderful.
and Kent isn't here. I know.
Yeah.
So I'm gonna.
That's okay.
I'm gonna pretend.
So right now, look straight up. Really.
That's what I was gonna say.
Yeah. Cancer. So zenith is what we describe when we're straight up overhead. Is what our astronomical term for zenith, and that is just about where Cancer is. So.
Is that
Look straight up.
M44? Is that the one you're going
Exactly. That'll be the one we're after first.
Look at me. Yes. Okay.
Yes.
Great. All right. So let me share the. This is called Stellarium, stellar with IUM at the end. It's free. It's planetarium software. And if I put in all the little circles and dots and everything, this is where we are headed. It's a nice, beautiful open cluster. It's right smack in the middle of Cancer. And if you want the pictures that go with things. You can kind of see it here, although this looks nothing like a crab. So, so if you go outside tonight, one of the things you'll notice is that there are no sticks, there are no labels on any of the stars. So how do you find this thing? Like Brian was saying, if you just go outside and look up, that's really a great way to do it. Another way just to get your bearings is it is between these 2 really bright stars, which are the twin heads of, it's Castor and Pollux for the Gemini twins. And it's also between the backwards question mark that you're going to see that is the part of Leo the lion. Okay, and so if you look here, if I take everything off, if you look between these 2, if we go outside, you look up, you see these 2 really bright stars, and then you kind of see this backwards question mark, and you're going to look right in between those 2. And you scan with your binoculars, and it's a really pretty object to see. And so, how'd I do, Brian? You ready to talk to people?
Yes, that was a great description. I agree.
Okay.
That'd be a great way to describe how to get to it. So what we're doing right now is I'm capturing an image so that my computer can compare the picture I am seeing here with where the Beehive cluster actually is located. So you can see how the computer says solved, or right here says plate solved. Mm-hmm. So it has figured out where my telescope is actually looking, and what it's doing now is it's actually moving the telescope to the proper location. And those squiggles are occurring because the telescope is moving as it's capturing fresh images. Now, with cameras like this is my camera is what's called a one-shot color. When we take professional astronomy images, believe it or not, they're actually black and white, and we put a filter over the black and white camera, depending on the color we're trying to view. So that would be one image for red, one for blue, one for green, and then even for special gases. But for outreaches like this, I use this camera, which is a one-shot color. But what that means is that the color balance is often off at first. And so I'm going to try to tweak this just a little bit so that I can see if I can get it a little bit better. So what I'm going to do is, before I start talking about this, I'm going to start what's called a live stack here, so it can start combining some images. And I need to reset it so that it's not super bright anymore. And as I start to gather some images, the computer program will combine them together. So you'll notice here it says frames stacked is 4 for a total exposure time of 25 seconds, and this is gathering up. Now that I'm gathering some images, I can stretch this, and then I can adjust the color. So that'll be a little bit better. Now, with the telescope that I'm using, because we were cloudy yesterday, I wasn't able to have my full-blown telescope aligned and calibrated. So you'll see this almost looks like you're looking through a tunnel. That's because we have to do special calibration to account for the light coming in the telescope. It's called a flat frame. So try to ignore the tube or ignore the circle. But let's see, I'm going to tweak this just a little bit. Okay, so as we go along here, this image will start to come into more and more focus, or I should say even more detail. While we're allowing these pictures to come in, let's talk about some facts for the Beehive cluster. As we mentioned, it's located within the boundaries of the constellation Cancer, and it's considered an open cluster. That means it's a loosely associated grouping of stars, and they have just about the same distance from us, is what we would usually say. Now, this one is estimated to be 577 light years from Earth, but really old, about 600 million years old. Now, this constellation, or I should say this object, this is not a constellation. We might call it even an asterism, which is just a grouping of stars that's recognized. But it's also known as Praesepe. And it has a funny spelling because it's Latin, but it's Praesepe. Well, that word means manger, which these names go all the way back even to Ptolemy, where he described this as having that kind of appearance. So I don't really see a manger, but these ancients were quite imaginative in their names. Now, this is an excellent binocular object and is also visible to the naked eye in dark skies. So if you're in a nice dark location, and we're very close, we're actually in a tiny sliver of a moon. We actually have a moon that's would have been very neat to look at tonight. Unfortunately, it's below my fence, so I can't show you the moon tonight. But Galileo, for this object, he was the first to document seeing it through a telescope way back in 1609. The last fact that I have for you is this is estimated to contain at least 1,000 stars. 63% of them are red dwarfs, and about 30% are similar to our sun. Now, with what I'm gathering with this telescope, I'm actually not able to show you the entire object here because of the magnification. So when you look at it with binoculars or a low power telescope, then you'll be able to soak in more stars than even I'm able to show you here. Yeah. So any questions come in?
Yes, you have quite a few people wondering about your program. Do you want to talk about it before you move away?
Oh, sure. I'd be happy to.
Yeah.
So this program that I'm using here is called SharpCap, and SharpCap is designed for this exact purpose. They call it electronically assisted astronomy. And so it gives me the ability to collect images. It's talking straight to my camera. This camera has a USB connection and is really treated like a video camera, but I can control the frame rate. In other words, I control how frequently it's capturing images. And I do all that from this right-hand side. So with SharpCap, then, as you've noticed, I can have it collect images and then stack them. And this allows us to put everything together. Just to talk about one other feature, what I really like with SharpCap is it's actually talking to my telescope. If you notice this little section down here, this is all of my telescope settings, and I can also change out the filters. So if I was looking, for instance, at a certain kind of nebula that would have a lot of hydrogen in it, I could switch over to a hydrogen alpha filter to bring out those details, which frankly is what happened to me, why we were here just the last minute with me setting up, because my telescope was set up for H alpha, and what I don't have yet is an electronic focuser, so I have to scurry out to the backyard when I change filters. So yeah, so that's the program. Yes, it is. Well, that's why we don't do these as often over the summer, right? Is because it's already so late by the time it's dark enough. And then it was still getting dark as I was setting things up tonight. So that's part of the adventure.
That is part of the challenge. I know we had some folks from the East Coast who were like, how come you're starting at 11 p.m.? It's like, well, telescopes
you have to talk to the sun about that, or the Earth.
And our telescopes are also on the West Coast, so
yes, they are.
Can't really do much about that.
No.
Okay, right. So let's see. You're getting some questions. Some questions are being emailed in too.
Okay.
People want to see your telescope. So because
Oh,
it's dark outside, we will share images of Brian's
yeah.
setup at another time. But yeah, if there's, yeah, that's what I'll say about that one. So
Right.
Brian, what do you want to, what should we do now?
I want to take a moment to talk about a NASA project.
Awesome.
So, yeah, as a NASA Solar System Ambassador volunteer, one of the neat things I get to do is gather information and share it about various NASA projects and missions.
Can we see your
And
face too?
I think so. Well, I did, though I had something I needed to share.
Okay. Hang on. I'll bring you full screen. Go for it.
Okay. So, this is what we're going to talk about. This is an image of the active radio traffic right now for the NASA Deep Space Network. And I'll give you some facts about it, but let me give you an orientation of what's going on in this screen. The NASA Deep Space Network is actually 3 different locations on Earth where they have collections of antenna that communicate with deep space. And deep space is usually considered anything not in Earth's orbit. So you can see we have a set of antennas in Madrid, and then we have a set in what's called Goldstone, which is actually very close to me. I'm about 40 minutes from Barstow, California, which is where Goldstone is located. And then we have Canberra in Australia. From these 3 sites around the Earth, they're about 120 degrees apart from each other. So that means that as the Earth is spinning, if they need to have mission critical communication 24/7, they can do so by transferring from one site to the next. By the way, I'll give you the link for this site. This is publicly available where you can see what each antenna is actually up to at any one time. So, for instance, I thought this was fun. In Madrid, their large antenna is actually talking to Voyager 1 right now at a measly 23.8 billion kilometers from Earth right now.
Whoa.
And so that is one of the other really fun things I find with looking at this status page is, so I'm going to click off of this. When you click on an antenna, when you see the squigglies, that's representing, right now you can see it's receiving, the little waves are coming in. When you click on an antenna, it'll tell you with these initials at the top what it's up to, who it's talking with. And then over on the right, you can actually get some facts about that spacecraft. So we could see it's talking to Voyager 1, 23.8 billion kilometers, and the round trip time for the radio signal, 1.84 days. And from this website, by the way, you can even look at the spacecraft. Now, this is not a live image of the spacecraft, right? That's a computer generated image. But let's talk about a few other facts about the Deep Space Network. This collection of radio antenna across the planet, they are what provide our communication pretty much with any mission that is outside Earth's orbit. But they actually do communicate or with a few missions that are in Earth orbit as well. But their main focus is interplanetary missions. But it's not just interplanetary missions, I should say. They have equipment that will also do radar and radio astronomy. So they will actually be looking at various deep sky objects or even objects in our solar system to gather radio and radar data from them as well. There's lots of neat things. Now, one of the things I was curious about, I have been out to Goldstone, and when you look up at that antenna, their big one here, each site has a big antenna. You're probably wondering, how big is it? Well, I'm going to tell you, 70 meters. Okay, so that's metric. I'm American, so, but a scientist too. So I'm fine with the metric system, but I had to look up a conversion because I wanted to compare that to something I could fit my brain around. So in feet, that's 230 feet. So we're talking about, if you might picture the satellite dish that you use to receive your television signal at your house. Well, this is 230 feet. And the best comparison I found is the wingspan of a 747, which is 225 feet. So it's actually 5 feet less is the wingspan of a 747 aircraft. These are big antennae. But because they're so big, that's why we're still able to talk to spacecraft that are 23.8 billion kilometers away. So the last thing that I want to share is the website for you. If you would like to go and look at this information, I find it's really unique to be able to know. Oh, by the way, this is all managed by JPL, by Jet Propulsion Laboratory in Pasadena. And then, of course, there's local people at each of the sites that help keep things going. So let me share my slideshow from this slide right here. And then I made this nice and big for you so that you could see it. So there it is. If you go to eyes.nasa.gov/DSN for Deep Space Network, then you can see that status information screen and then learn more about the various antennae they have at each site and the spacecraft that they're communicating with. Okay. All right. So any other questions coming from about this before we move on to the next object?
No, I think we're good. There's a couple of equipment questions, but we'll handle those near the end.
Okay. Sounds good.
Yeah.
Well, let's see. Where should we go next? Let's go to another open cluster in Cancer. I tried to choose some objects that wouldn't be too far from each other.
I know the one you're going to. Yeah, I think I know the one you're going to.
Yes, M67. Right.
Okay, here, let me get you full screen again.
Okay.
Okay, so where are we now?
So we are going to go to M67. So this is the other program that I use in my suite of software here. This is called Starry Night. So Starry Night is also talking to my telescope. So I can search on an object, and I've typed in M67, and I'm selecting SLU, which is the term for the telescope moving. And if I look around, so you can see here that little plus sign represents where my telescope is pointing. And if we're lucky, then it would actually be in the view. Now I need to cancel my stack, reset a couple of things here. Okay, and so it is not on target, so we need to do a new, stretch that so I can, actually we do have it.
You do have
let's
it,
see
look
if we,
at that.
Yeah, let's
Nice
get it
job.
centered. And thank you. I'll go out and give my telescope a nice pat for actually getting to the right
No,
object.
don't touch the telescope now. What are you kidding?
No, not right now. I am going to do a plate solve while so that I can get the best image possible.
All right, plate solve. You want to define that for our
Yes,
audience?
absolutely. Thank you for catching that.
Yeah.
So plate solve refers to comparing the location of each star in the picture to a database so that we can confirm where it actually is in the night sky with what we're aiming. The term plate solve actually comes from the time when astronomical photography was done with photographic plates made out of glass. They would literally have glass plate, put the photographic film across it, the chemicals, and then they would connect it properly to the telescope, capture the image, and then process it. Harvard actually still has a very big library and other universities of photographic plates captured all the way back even into the 1800s. So when we say plate solving, that means we're comparing the picture to a database, and they actually have many of these stars, I should say, specifically mapped out to their coordinates. And by my computer comparing the picture I took to its database, it can actually figure out how far or how close it is to what I'm after and then make the adjustments. It's a pretty amazing feature to have in a program that's actually available for free. Okay. Oh, no, I canceled that. I did not want to plate solve. So let's start a new live stack here. Okay. And then...
while Brian's doing that, let me just flip over really quick on the to the Stellarium program. So this is where we were in Cancer. So we were looking right between these two stars for M44, and then M67 is right down here. So if you go to this side, you'll look and there's no open cluster there. But if you look down here, you're actually going to be heading towards the head of Hydra. Okay, you'll also see the bright star here in Canis Minor. And you'll be able to see this one. So if you see the backwards question mark and you see the foot, you want to go down the question mark as that's oriented, and you go, that's the direction you're going to be headed. Okay, where are you? Where are you? You are.
All right, thank you.
Excellent.
So great. So now we have a image that is being live stacked. This is now a total of 40 seconds, but then I've done some color correction. And I really actually like this cluster. To me, it reminds me more of a globular cluster, which is where the stars are gravitationally bound to each other. But we can see we're much more tightly packed. This makes a little more sense to me on why this would be included in Messier's catalog. Reminder, this is Messier 67 or M67, and Messier was a comet hunter, so he was making a list of objects that might be confused as a fuzzy comet when looking through the telescopes of the time. And so a tightly packed cluster like this could look like a fuzzy, especially with the level of optics they had way back then. But this was actually discovered by a German astronomer named Johann Gottfried Kohler way back in 1779. Now, this one contains over 100 stars similar to our sun and is absolutely another good binocular object. So I definitely recommend you can, if you have clear skies where you are, you can look straight up and see if you can find the beehive and then this open cluster. By the way, I've heard this one be described as different nicknames. Stellarium is really good about gathering about every nickname an object seems to be able to have. The Golden Eye cluster seems to be the top nickname for this, but it's also been described as the Pac-Man cluster. And I'm not quite sure how they're getting that, but maybe if this is the mouth and that's the round part of Pac-Man, maybe. So that's what I had to share about this object. And so, Aurora, I'm not able to hear you at the moment. So I'm going to go ahead and work on going to our final object. And
that
Aurora,
sounds great. While you do
there
that,
you are. Okay.
Here I am. Sorry. I'm going to take over for a second. Thank you,
Yes.
Tom. I understand I had no cursor. So, yeah, Stellarium likes to fight with Zoom and YouTube. So sorry about that. So here is the one we were just looking at here, M67. And as far as I can tell, I have a cursor now. And so this is where...
Yes, I'm seeing one.
You're seeing one? Okay, great. This is where we want to go. So if you were looking at the backwards question mark, you just go straight over. It's actually halfway between the bright star in Canis Minor and the foot of Leo the Lion, right there. All right. So where are we going next, Brian? You're the one who's driving this spaceship.
Yes. Our last, but definitely not least object for tonight is M104, the Sombrero Galaxy. And this is actually one of my favorite objects in the night sky. And it is actually between Corvus and Virgo. So this is moving into more really of definitely a spring object, but even into summer, really. But it is a very good telescope object. Now I'm going to need to reset my views here. This is moving farther to the south, so it's going to take my telescope a hot minute to get there. So it looks, in fact, like we're still moving a little bit.
Seeing you figure this out.
What's that? The audio cut out for
I said, I think people like seeing you figure this out. So
yeah.
I'll wait till we get a good view of it. Then I'll show everybody
Sounds
what it is.
good. Okay, sounds good. So part of the problem is I'm still up at 5 seconds. I'm going to drop this down to 1 second. By capturing smaller slices of time, that allows me to see what the telescope is capturing faster as I make adjustments. And so, okay, now that I have that, I'll go ahead and try a plate solve, which we now know is it's comparing the night sky. Now, one of the other things that is happening here is we're now looking much lower to the south, and that means we're down closer to the horizon, which means we are getting more atmospheric interference. We talked about zenith, which is straight up. Zenith is always the best view for the clearest skies, the least amount of air movement. But as you move down towards the horizon, especially right after sunset, then we start to see a lot more movement in the air. Now, the plate solve failed, but we actually have it there. Now, something interesting is happening. I'm concerned that my telescope actually is not tracking because you notice how it's actually moving between images there?
See that?
But that's actually M104 right here.
Oh.
But what I need to do is I'm actually gonna see if I take some smaller images, I'm gonna see if I can really make my computer earn its keep and start stacking some very small images. So nope, so far it is not. So I'm concerned that what may have happened that I moved so far away that my telescope may have snagged a cable, and so now it's actually stopping it from moving along and tracking as it goes. So that is a pretty bad picture of M104 right there.
Well, do you want to go see if you can fiddle with things for a minute?
Yes, if we have a minute to do that, I will.
Yeah.
I will definitely go do that.
Why don't I answer
right
some
back.
of the questions that have been coming in, and
awesome.
I will show everybody where this one is. All right, so
Okay,
M104.
great. I'll be right back.
Oh, unless you're talking, go ahead.
No, go ahead. Sorry, I was just saying I'll be right back.
Oh, okay. All right. So, so while Brian is, welcome to astronomy, right? All right. So while Brian is doing that, let's take a look at where Corvus is. Corvus is a cute little small trapezoid, not quite a parallelogram constellation. Basically, if you go outside and you look south, between south and east, it'll just be right above the horizon, at least where where I am living. And you'll find it right next to another 4 stars that form another trapezoid, not quite a parallelogram. And we're looking right in between. And the Sombrero Galaxy here is M104. It's actually one of my favorite objects too. So this is an image, I want to say this is an image taken from Hubble, but I could be incorrect. And I'm sure all my astronomer friends now are going to tell me where this image is from because I do not remember. Okay, so this is M104. So if we were going to go outside and take a look, this is what you'd be looking at. So here's Corvus and here's the body of Virgo, and you're just going to look between the two of them. Okay, great. So that's where we're going to be looking. And then let's go ahead and chat about equipment. So those of you that are on the chat and able to share with me, why don't you tell me what either your favorite telescope or piece of astronomy equipment, could be a pair of binoculars, that's totally fine too, either that you currently have that you're really wanting, or that was your absolute favorite and for some reason you don't have it anymore, or something of that nature. So everybody should have an opportunity to put something in. So if you've always dreamed about owning a 20-inch obsession, put that in there. So what is your favorite piece of equipment to use? Or if it's, it could be telescopes, binoculars, could be a favorite eyepiece, put that in right now. I'd love to see what you guys enjoy. I can tell you from, for equipment, you know, to get started with astronomy, these are your best bet. Everybody wants to buy telescopes and nobody wants to pay for them, so they get one from Walmart or Amazon or what's the other place, Costco. And so that's actually the quickest way to kill your passion for astronomy, because they will drive you crazy because they're really poor pieces of equipment. And in order to really get started with the hobby, you're looking at least several $100s. And so the best thing to do is get an inexpensive pair of binoculars, borrow them if you can. These are $30. These are Celestron Cometrons. These are 7x50. 50 refers to how big this is here. This is 50 millimeters. This is the where the light comes in. And then the 7x refers to the magnification your binoculars will have. You won't see that kind of specification on a telescope for a couple of reasons. If you ever see anything that says 1200x magnification on the box of a telescope, you just put it down and walk away. So we don't measure telescopes by what their magnification is. We measure them by light collecting ability. And so the more light we have, just because what we're looking at dim. So the bigger the telescope, the bigger that mirror is, the more light that can come in, or the bigger the lenses are if it's a refractor, the more light we have, the better we're going to be able to see things. Somebody was asking about, I'm not seeing color, the way Brian's camera is just describing it. That is true. It's because our eyeballs are fantastic at a lot of things. One of them, acting like a camera, not so much. And so Brian is able to show much more with the images you're seeing. When you are to look at these things, especially things like planetary nebula, even if you're looking at the Andromeda Galaxy, when you look at those things, they're going to kind of have a greenish grayish tint, because that's what your eyes are tuned for. And also, they're, depending on what it is and how good your seeing is, they're going to be fuzzy. They're not going to be these beautiful, crisp pictures. So that's why we always like to show you what it looks like at the telescope first, and then we'll show you photographs later, because then you can go, wow, right? Because otherwise you go the other way and you see these Hubble Space Telescopes are now pretty soon some of the bigger observatories that are going to be coming online in the next couple of years. Yay! You'll see those, and then you'll go to a telescope and go, oh, that's it? So look at the telescope first. Just the fact that you look through it is just amazing. Okay, so let's take a look at what equipment you guys are using, and then tell me what the first object was that you actually looked at through a telescope. So what is the first object you looked that blew your socks off? Okay, so first object, or the first object that blew your socks off and you were like, whoa, this is amazing. Tell me what that is right now. Let's read a couple of these off. Let's see, I want a gigantic telescope. Yeah, me too. Okay, let's see. Other question, lots of questions are coming in here. I have Celestron binoculars. Excellent, me too. And let's see, the telescope is using, I have an 8-inch Celestron. I have an LX200. Okay, so some of these are coming in. So we're streaming to 5 streams simultaneously. Just so you know, we're on Facebook, we are on YouTube, we're on a private live stream right now. Brian and I have Zoom going, and some people just email things in. So let me check a few other places for all of our questions. So if you're not seeing like the things I'm calling out, that's why. Okay, and so yes, things that you're looking at. I love this. Thank you so much. The video froze for 20 minutes. I'm so sorry. So yes, go ahead and feel free to try a different. That's one of the reasons we do multiple live streams, because if one isn't working, there are other options for you. Okay, great. My first telescope was the full moon. That was, oh, ow, yeah. The person put ouch in it. So I think, is that Sophia that I'm seeing that? Excellent. Yes, you don't want to be looking at the full moon with the telescope, not even with your eyeballs. Okay, and Saturn, a lot of Saturns are coming in. Excellent. Jupiter was your first object. Okay, great. Let's see, George Westland. Hi, George. You have a Meade 5.5-inch reflector, upgraded to Plossel, and yes, excellent. Seeing the double star Albireo. That was your first object? That's amazing. So they're talking about in the eye of Cygnus the Swan, there's a binary star system. We think, I actually had to look this up because of course the students are always asking good questions. As far as I know, it's an optical illusion, so it's not a true binary. They actually just look like they're close. But one is kind of an orange color, orangish yellow, and the other one is a blue. If you want to see where that is, that's more of a summer object, but here, we'll take a look since Brian is still tweaking his telescope. If you want me to show you where things are, I'd be happy to. We can do that too while he's looking. We just had this one last object to do. So we're going to put, no, here, we'll just put Albireo. I'll put the brackets on it so you can see it. Okay. All right. So in the summer, what you're going to do is you're going to go out and look pretty much straight up. As soon as the sun goes down and it's dark enough to see stars, you will go and look straight up and you will see 3 big bright stars. Okay. And so one of these is Vega. And this is my favorite constellation in Lyra or Lyra. This is Altair, and this one here is Deneb. This is the rear end of the tail star of Cygnus the Swan. And if we put the swan in here, you can see the wings. You see how the stars kind of line up with the wings? And then you see the head right here? This is Albireo right there. And so if we were to zoom in here, we don't zoom in with a telescope, but if we were to look at this through a telescope, it doesn't take much, like a 5 or 6 inch or greater telescope, you'll actually see those two separate stars. You want to look at more two. Okay, so another double star, I would actually go with the Big Dipper. So here, let's go look at Mizar and Alcor. Okay. Aren't those cool names for a star, by the way? Mizar and Arc. It's like, finally, a name I can pronounce, and it sounds cool. Okay, so let's take a look at, do you see where the Big Dipper is? Everyone see the Big Dipper? Here, I'll put the little things in if you need them. Okay, there's the Big Dipper right there. So we have 4 stars in the bucket, and we have 3 stars in the handle. 4 if you include this, double count this one. Okay, so if you go to this one here, way back before you and I were around, I don't know exactly how long ago, but this was a test of your eyeballs that people would use. If you could see 2 stars and kind of split this and see how it's not round, it's kind of an oval, then people would say, oh, you have good eyesight. If you only saw 1, they would say you don't have good eyesight. So that was the way they used to do it. In binoculars, it'll look like this. And each one of these, this is Alcor, it's the smaller, fainter one. This one will split into 2. Mizar actually will split into 2, and then each one of those will split into 2. So this is a 6-star system right in here, right in the handle of the Big Dipper. Yeah, there's a lot of fun stuff in the Big Dipper. Since we're here, if you would like to see another galaxy, this one requires dark skies. Do you see it yet? It's right here. This one is M51. This is our Whirlpool galaxy. Okay, this is, somebody had asked before about seeing it. I have not seen that one in binoculars, but I guess if I was a kid and I knew where to look and the sky was nice and clear and bright, I might be able to do that. I see Brian is coming back online. Yay! Okay, so that was right off the end of the handle of the Big Dipper. Yeah, there's a lot of fun stuff in the Big Dipper. Brian, how are you doing?
Yes, I'm good.
All right, let's flip over to you.
Yes. Okay, very good.
So tell us, what are you up to?
So the telescope is on the Sombrero Galaxy, and so we're here. We're actually still not able to stack some images. So this is 1 second exposure, but what we can see from this is we can see that we're looking edge on with a galaxy, and even with this, we can see the distinctive feature of the Sombrero, which is a dark dust lane really running straight down the edge. So I think that for tonight, this is about the best we're going to be able to show the Sombrero, and I'll definitely try to show this another time when I have a telescope that's cooperating a little bit more.
No problem. What happened with the telescope? Were you able to figure it out or no?
So what my best idea with this telescope, in order to set up a scope quickly, this one actually is an altitude azimuth scope. In other words, it goes straight up and down and then left and right, but then has a GPS and computer control. The best way to track with a telescope is called equatorial, where one axis is always pointing north. But that requires, for an ideal lock, we have to be able to see the North Star to do all the settings. And since I had to set up during the daylight, I needed to use this telescope. So when you use an altitude azimuth telescope like this one, this is called an AZ Mount Pro. When you move to the opposite side of the sky, then it oftentimes gets confused in its tracking. So in order to truly fix this, what I have to do is have it pick out 3 different stars across the night sky, and then we lock all 3 of those into place, and that allows it to control the timing on its motors more precisely. So it's a little more setup than I was able to do since we set up during the daylight.
I was glad you shared live views with us this time. Yay!
Yes, yeah, I know. I'm glad we didn't have to just look at clouds.
Do you want to answer the questions about what kind of telescope you have and what?
Sure.
People are asking what eyepieces you're using in your.
Okay.
So go for it.
Yeah, and so absolutely, I'll do that, and then I'll share just a couple of facts that I have about the Sombrero also.
Oh, why don't you do the Sombrero first? That's fine.
Okay. So the Sombrero is a Messier object, and it comes in at 104 in the catalog. Now, this is considered an unbarred spiral galaxy. Sometimes when you look at galaxies where you can see that pinwheel type shape, as Aurora was describing with the Whirlpool, then you see a distinct bar literally coming out from the center. With all of their tests and analyses, they don't see bars with this one, but it is far away. 29.3 million light years away is the estimated distance. was actually discovered by Pierre Méchain in 1767. My last fact, but I find very interesting with this, is scientists are very excited with what they are detecting with the X-ray spectrum emissions from this galaxy. What's happened is they're detecting a ridiculous amount of X-ray light coupled with unusually high stellar velocities caused close to the core of this galaxy. Now, what does that mean? That means that when they look at their high resolution images and analyses with radio telescopes, I wonder if some of the Deep Space Network telescopes have been used for this. They're really thinking that there is a supermassive black hole at the center of this galaxy. Their estimate would be this would be an object that is about 1 billion times bigger than the mass of our sun at the center of this galaxy. So it'll be, as we have some more powerful telescopes coming online, not the least of which would be James Webb, it'll be interesting to see what they learn about the core of this galaxy as they analyze these more. Yeah. So, all right. So on to some telescope questions. For my setup tonight, I'm using a Celestron C8. It's a telescope that's called a catadioptric. What that means is if you're looking at it, it looks like a tube and light comes in the front and then it actually bounces through some mirrors and then comes out the back down the middle of the tube. So that makes them nice and short. They sometimes call them a folded light telescope. With this right out the back, I actually have my camera connected right where an eyepiece would go. So that's what's neat, is that there is no eyepiece when you're doing photography like this. Really, the camera is your eyepiece. So this camera that I'm using then, it has a chip similar to what you'd find in a video camera or a digital single lens reflex camera, but there's no lenses in the camera itself. It uses the telescope as your lens. And then the mount, what I normally use is I use an Ioptron 70 mount. It's called a 70 GEM. And that one can be very precisely calibrated and even has its own little tracking camera so that I can tell it, hey, you see that star? Stay there. And it will follow and make microscopic little adjustments to follow that star as the Earth moves to keep things precisely locked on. So hopefully when we move back into some shorter days on our next presentation, then I'll have that mount up and ready, and then we can show some much more crisp images than we can show with this setup tonight.
Awesome.
Any other questions come in regarding hardware?
Yes, I have a couple more questions. Other questions are, let's see, other questions, I'm trying to...
I'll go ahead and stop my share now.
Yeah, okay, let me get both of us on. There we go. Hi.
Hello.
Hello. Okay. Let's see. A lot of people are sharing their equipment. It looks like, I think you got most of the questions about where to find things, and we covered the binocular question. So yeah, I think we're good, unless you're seeing anything else showing up on your side.
So I saw that we had a question asking if we could show an X-ray pic. So no, I haven't gathered any X-ray images, but you could definitely go and search online. You could look up X-ray Sombrero Galaxy, and you could see. Now, keep in mind, when we're representing data that's coming in X-ray, then what's happening is the computer is actually having to convert that into something that we could see with our eyes. So they often call that a false color image, I believe, where they'll use certain colors to represent different wavelengths of X-rays.
Yeah.
So I think that's the only other question I'm seeing. Yeah.
Yeah, I think that's what everybody. I think it's most of the questions. I think Jackie was asking about volcanoes, but we just don't have that data at this time, so we just don't know. So it's hard when what you're studying is hot and likes to melt things and bake things and crush things. And somebody I had given a presentation at one point, and I was talking about, do you know what the Venus was named for? And the the audience, there were like 200 people, and they're like, no. And I said, well, you know, it's named for the goddess of love, the goddess of beauty. And then we started talking about what Venus is like, and this lady stands up and she goes, well, it's a good thing we didn't know back then, or we might have named it something worse.
That's funny. Yeah, it is a very hostile planet.
Yes. So, yeah. Anyway, I think we're good to go. So if you guys, Brian, go ahead. Did you want to share?
Oh, sorry. I just was going to mention, looking at Jackie's question, can volcanic rocks leave Venus' atmosphere and enter our own? I think that would be very unlikely because it would have to actually move farther out away from the sun. That would be a lot of velocity, I think, for it to leave Venus and then be able to come to us. Yeah. We know that we do have some meteorites that have come from Mars and the moon and come to Earth, but we're not aware of anything that's come from Venus or Mercury as far as I know.
Right. Let's see, I am getting the questions here. Tom is asking, when is the next stargazing event that's live and in person? I was hoping to be able to announce dates to you tonight. I am still talking with the ranger to arrange dates, so I apologize. I meant to have that ready for you. I still don't have it ready. My hope is in May and June, I'm hoping May, but for sure June, July, August, September, October, we will be live stargazing at our regular site. And so if you'd like more information about that, go to centralcoastastronomy.org, and we'd love to see you. Those of you who like to travel and would like to see us in person, we would love for you to come and stargaze with us, and all of that information will be posted on the website as soon as I have it. So I'm sorry, I wish I had it. Brian, are we expecting to stargaze in May, or is this the last one for the season?
This is the last one because it would be so late for us to be able to actually show live telescope views. So our plan, as I understand it now, will be to pick this back up in the fall. Yep.
So we will pick this back up in the fall. It has been our pleasure to be with you tonight. You can still watch the... when we stargaze and when we did all those shows with Kent every single month, and so whenever that month rolls around, all that information is still relevant. So you can go back to our website, which is here. Let me show you really quick. You can go to centralcoastastronomy.org, and then what you'll do is you'll click on stargazing, and do you see where it says month by month stargazing tours? So what Brian did is he put all of those shows together that we had done, and so you just go down to the appropriate month. So we are in April, for example, and you click on this and it'll open up. This is the handout that we had put together for April, and then this is the actual show that you can watch. And so we have those for all 12 months. They're really good. I think they're really good. And so, so thank you, Brian, for compiling
so much information. You know what? Oh, you're welcome. It's my pleasure. And you know, one of the things I find that's wonderful is with Kent's descriptions, you can simply have that recording playing. Don't look at the screen, and it's like Kent is right there with you, giving you a tour of the night sky. You can look around, right, just by listening along.
Awesome. Well, thank you everyone for joining us. Your job is to go outside, look up, and go practice seeing some of the things that we had talked about for tonight. If you have any questions, let us know. I'm Aurora at centralcoastastronomy.org. Brian is Brian at centralcoastastronomy.org. We're happy to help, and we look forward to seeing you live in person. And if not, we will see you at the next one that we do. You'll get information about it. It'll be posted on our website, and I will see you soon. Bye-bye, everybody.